This isn't natural. On June 13th, 2026, the ground in Yellowstone's Biscuit Basin split open. And this time, it happened close enough to a brand new monitoring station that scientists didn't just hear about it afterward. They watched it happen. Water hot enough to cause third-degree burns in under a second blasted into the air. And here's the detail almost nobody reported. This is the second time in 2 years that this exact stretch of boardwalk has done this. Not nearby. Not similar. The same corner of the same basin. That detail, why the same spot keeps doing this, doesn't get answered until later. And it's not even the strangest thing about Yellowstone's hydrothermal system. Somewhere in this park, hidden in plain sight, is a crater so large it could swallow an entire American city. You've probably driven past it without knowing it was there. We'll get to that. First, you need to see what actually happened on the ground that day. It's mid-morning in Biscuit Basin, a quiet corner of Yellowstone about a mile northwest of Old Faithful. Tourists walk the boardwalks near Black Diamond Pool, the same pool that made headlines in 2024 when it blew a cloud of scalding water 50 feet into the air, caught on video by stunned visitors. This time, the explosion isn't at Black Diamond Pool itself. It's close by. Close enough that USC scientists immediately connected the two events as part of the same restless hydrothermal system. The ground doesn't collapse dramatically, like something out of a disaster movie. It's faster and stranger than that. A crack opens. Superheated water sitting just below the surface at temperatures pushing past boiling finds a weak point in the rock and mineral crust and forces its way out. Steam and near-boiling water surge upward and outward, and within seconds, the water is pouring directly into the Firehole River, turning the current cloudy with sediment kicked up from deep underground. Nobody was standing on top of it when it happened. That's not luck. Yellowstone's hydrothermal areas are unpredictable enough that park rangers have spent decades hammering one rule into every visitor: stay on the boardwalk. But get this. A few days later, when scientists returned to survey the site, they found something new. A pool. An entirely new hot spring, bubbling away where solid ground had been less than a week earlier. Let that sink in. The landscape of Yellowstone had physically rearranged itself in a matter of days. Now here's where most coverage of this story gets it wrong, and where the panic usually creeps in. People hear Yellowstone and explosion in the same sentence, and their brain jumps straight to the supervolcano, the one capable, in a worst-case scenario, of altering global climate for years. That is not what happened here. And understanding the difference is the entire key to this story. Yellowstone sits on top of a massive magma chamber, yes, but hydrothermal explosions like this one have almost nothing to do with that deep magma system directly threatening to erupt. Instead, picture something more like a pressure cooker buried under a national park. Groundwater seeps down, gets superheated by heat rising from the magma system far below, and becomes trapped under layers of rock, clay, and mineral deposits. As long as that pressure stays balanced, nothing happens. But when something shifts, a crack forms, an underground seal weakens, even something as simple as heavy rain changing the water table, that pressure has to go somewhere. And when it goes violently. This is happening constantly at Yellowstone, on scales too small for anyone to notice. Most hydrothermal explosions are the size of a dinner plate. But every so often, the pressure release is big enough to throw rock, mud, and boiling water dozens of feet into the air, like it did at Black Diamond Pool in 2024. And like it did again here. Here's the thing nobody tells you on the average nature documentary. This has happened before. Many times. And once you start looking at the history, the 2024 and 2026 Biscuit Basin explosions start to look less like a warning sign, and more like Yellowstone, simply being Yellowstone. In 1989, At Porkchop Geyser in the Norris Geyser Basin, decades of quiet, steady eruptions suddenly ended in a violent hydrothermal explosion that hurled rock debris 15 feet in every direction. Visitors who had watched that same geyser bubble peacefully for years came back to find a crater where a spring used to be. The rock apron from that explosion is still there today, if you know where to look. Go back further to the 1880s and Excelsior Geyser in the Midway Geyser Basin put on an even more violent show. A series of explosions so powerful they threw boulders 50 feet from the vent. Excelsior was so unpredictable that it eventually stopped erupting as a geyser altogether and became one of the largest hot springs in the world instead, permanently rearranged by its own violence. But those events are small compared to what happened at a place called Mary Bay. And this is the part of the story that should genuinely change how you think about this park. Along the northern edge of Yellowstone Lake sits a crater 1.5 miles wide. Most of it is underwater now, quietly disguised as part of the lake itself. Roughly 13,800 years ago, that crater didn't exist. Then, in a short and violent sequence of events, the ground exploded, not once, but in a rapid cascade of blasts, sending a plume of water, steam, and shattered rock an estimated 6,000 feet into the sky. That's 10 times higher than the explosion that made headlines at Biscuit Basin in 2024. 10 times. Geologists studying the site have a theory, and it's almost stranger than the explosion itself. A major earthquake struck the lake floor, triggering a tsunami that displaced enough water to drop the lake's level by nearly 45 feet in a very short window. That drop in water level meant a drop in the weight and pressure holding the hydrothermal system down. With the lid effectively lifted, the superheated system beneath Mary Bay let go all at once, in what one Uskis scientist described as a cascading sequence of hazards. Not a volcanic eruption, not molten rock, just pressure, water, and geology doing something almost unimaginably violent. And Mary Bay isn't even alone out there. Keep going around the lake and you'll find Turbid Lake, a crater over a mile wide formed roughly 9,400 years ago. Elliott's Crater, nearly half a mile across, blasted out about 8,000 years ago when an earthquake ruptured an underground dome of pressurized gas and fluid. Indian Pond, a smaller crater from around 2,900 years ago. 4 separate mega explosions, 4 separate craters, all sitting quietly around one lake. And almost none of Yellowstone's 4 million annual visitors have any idea they're driving past them. That's the part that should really sit with you. This isn't ancient history in the sense of being over. It's ancient history in the sense of being a pattern. A park that has done this again, and again, and again for at least the last 14,000 years. The only real question is where the next one happens, and how much warning anyone gets. Which brings us back to that new monitoring station, and why this particular explosion in June might matter more than any hydrothermal event Yellowstone has produced in decades. Scientists have spent decades trying to predict when and where these explosions will happen next, and they've been working almost entirely blind. Most hydrothermal explosions are documented after the fact. A hiker hears a boom. A park camera catches something in the distance. By the time researchers arrive to study the site, the event itself is long over, and all they have to work with is the aftermath. A crater, some scattered debris, maybe a new pool where there wasn't one before. This time was different. USCIS had recently installed a new seismic and thermal monitoring station in Biscuit Basin, close enough to the explosion site that it captured the seismic signature of the event as it happened, along with temperature and pressure data in the critical minutes before and after. For researchers, that's not just interesting. That's the single most valuable dataset anyone has ever collected on how a hydrothermal explosion actually builds and releases. Think about what that means. For the first time, scientists have something close to a real-time recording of the exact moment the ground decided it couldn't hold the pressure anymore. Every previous explosion left them reconstructing the crime scene after the fact. This one, they practically watched unfold on their instruments. And here's the piece that connects everything back to why this matters to you. Whether or not you've ever set foot in Yellowstone. Roughly 4 million people visit Yellowstone National Park every year. A significant number of them walk directly past areas where hydrothermal explosions have happened before. Biscuit Basin included. Norris Geyser Basin included. The shores of Yellowstone Lake included, whether they realize it or not. The boardwalks, the warning signs, the rules about staying on marked trails, all of that exists precisely because nobody can currently predict, with confidence, exactly when or where the next explosion of this kind will happen. That's the gap this new data might finally start to close. If researchers can identify the seismic and thermal warning signs that preceded this explosion, subtle shifts in underground pressure, tiny temperature spikes, small tremors too faint for a human to feel, they may eventually be able to give park rangers something they've never had before. An early warning system for a hazard that has, until now, always struck without notice. Compare that to how far earthquake science has come. A century ago, earthquakes simply happened, without warning, and people dealt with the aftermath. Today, some regions have seconds to tens of seconds of warning before shaking arrives, enough time to stop a train, open fire station doors, or duck under a desk. That head start didn't exist until scientists spent decades building instrument networks and learning to read the signals that come before the shaking. Hydrothermal explosion science is sitting roughly where earthquake science was generations ago. This explosion and this monitoring station might be the first real step toward changing that. USCIS has been careful, and honestly they're right to be careful, in how they've framed this event publicly. Their statement was almost dismissive in tone. This is not a sign of an imminent eruption. This is not connected to any change in Yellowstone's overall volcanic threat level. This is the hydrothermal system doing what it periodically does. And scientifically, that's completely accurate. But there's a difference between this isn't dangerous to the planet and this isn't worth paying attention to. This is one of the most information-rich hydrothermal explosions ever recorded at one of the most visited hydrothermal landscapes on Earth. So what happens now? Researchers are already analyzing the data from that monitoring station, comparing it against the handful of other instrumented events on record. The new pool that formed after the explosion will be watched closely. Sometimes these newly formed features stabilize into permanent, if unstable, hot springs. Sometimes they quietly fill back in within a season. Either way, Biscuit Basin now has one more monitored feature that scientists will be tracking closely for years. And Black Diamond Pool, the site of the dramatic 2024 explosion that first put this stretch of Yellowstone on people's radar, it's still there, still active. Still part of the same restless hydrothermal network that just proved, once again, it isn't finished rearranging the landscape beneath the boardwalks. There's a broader research effort underway too, one most visitors never hear about. Scientists have spent recent years pulling long sediment cores from the floor of Yellowstone Lake itself, drilling down through layers of mud and debris that record thousands of years of hydrothermal history. Buried in those cores were signs of at least 16 separate explosion events. Some large, some small, some previously unknown entirely. A hidden timeline of violence stretching back 14,000 years. Written in layers of ash and shattered rock at the bottom of a lake, most people only ever see from a scenic overlook. That timeline is exactly what makes events like the one in June so valuable. Every instrumented explosion is another data point connecting the ancient record buried in the lakebed to the physical process happening in real time under a boardwalk full of tourists. Slowly, painstakingly, scientists are building a bridge between this happened thousands of years ago and here's exactly how it happens. None of this means Yellowstone is becoming more dangerous. That's an important distinction, and it's worth being direct about it instead of dancing around it for views. The frequency of small hydrothermal explosions hasn't measurably increased. What's changed is simply that scientists, cameras, and social media are paying closer attention than ever before, and a park that was already doing this constantly is finally getting caught in the act. But not more dangerous and not worth understanding are two very different things. Every visitor who steps onto those boardwalks is walking across the surface of a system that has, at various points over the last 14,000 years, blasted craters over a mile wide into solid ground. Most of the time, it does nothing more dramatic than steam gently rising off a colorful pool. Every so often, without much notice, it doesn't. Remember that new monitoring station we mentioned at the start? The one that happened to be sitting almost exactly where it needed to be? That's not a coincidence anyone should take for granted. Instruments like that don't get placed randomly, and they don't always end up this close to the action. This time, they did. And because of that, an explosion that would have once been just another mystery crater might end up rewriting how we understand one of the most visited and least predictable landscapes on the planet. And remember Mary Bay? That 1.5 mile wide crater sitting quietly under the surface of the lake, formed by an explosion 10 times more powerful than the one that made headlines in 2024? It's still there too. Still part of the same lake family's photograph from scenic pullouts every summer. The system that built it hasn't gone anywhere. It's just been patient. So here's the question worth sitting with. If scientists eventually can predict these explosions the way they predict earthquakes today, would you trust an early warning system enough to still walk those boardwalks? Or would knowing a warning system exists be exactly the reason you'd think twice before booking that trip?